Well, there we go. So our input, very simple amount of input. We've got two things. We're going to input our surface. That's the surface. And when you picked your topo that you were going to forward with, you should still have that surface, that height filled surface that you made. And then the other input's going to be that spline that you picked. Those are the two things that we're kind of throwing in. The output's going to be the new model ready to fabricate. So I'm in kind of where we left off. If you would have all your surfaces here. To keep my file small, I've only got one. And this is going to be, for me, the surface that I go forward with. This is my selected topography. I'm going to copy that into my clipboard in Rhino, and I'm going to open up a new Rhino file, and this will kind of be my working file here. I'm going to do small objects, inches, like that, and I'm going to give myself a couple new layers. Some of this stuff's going to come in with its own layers because we're copying and pasting, but we're also going to have a topo poly surface. We're going to have something called bottom curves. We're going to have another layer called top curves. We're going to need to have nested sections. We're also going to need to have nested numbers. And we might need other ones along the way, but those are the ones that we can kind of start out with. Yeah, we're also going to need one called sections for sure. Okay, so I've got that surface on my clipboard. I'm going to Control V, the Windows paste that thing into my model. It's going to come in wherever it was before. So I'm going to move it to be at my origin point. I want my left bottom corner to be at the 0 point in Rhino. So I'm going to use the turn on the end snap, and I'm going to use project. Project allows me to pick things no matter where they are in space and move them down to the C-plane. So my snaps project down to the C-plane. It allows me to work in almost like a two-dimensional plane no matter where my geometry is. I'm going to go to move under transform, and I'm going to move my object. With that end snap, I can snap to that corner there. You can see the project in white with it off, and we can have it off and it'll go to that end point, and when I turn it on, it projects it downwards. And then for point to move to, I'm just going to type in 0 to get my surface at the origin point there. So that's my one piece I've got. I'm also going to have something called, and you can see that this red layer here is the imported layers. It remembers the layers. I'm also going to have a, I'll just call this a reference box for lack of a better word. I'm going to have a reference box as well. So the next thing I want to do is I'm going to draw this reference box. This reference box is going to get our surface basically at the right height. So I want to go and use the box command, which is under solid, and do a box. My corner is at 0, and my other corner of base or length is going to be the same size as my drawing. So my drawing is going to be 30 by 22. And my height is 9. Actually, right now I'm going to do my height at 8. Now this is making an assumption when I do this kind of this reference here. It actually be I've got it at the wrong height, but more importantly, the assumption is that this thing is perfect in terms of being 30 perfect and 22. It might not be that. Because your image, when you cropped it, might be slightly off. Illustrator is a less precise tool than Rhino is. So this thing might be slightly bigger or slightly larger. One way I can look at that, and I'll show you that in a second, but the first thing, I skipped that first step, what I needed to do, and that was to scale this surface down. So we're still going to have the reference box, but we want to scale our surface down. Our model is not going to be This size, it's going to be half this size. So right now, I'm going to do a transform scale 3D. My origin point is 0. And by default, it wants to do a uniform scaling, so I can just type in as my scale factor up here, 0.5. And that'll scale it down to half the size that I need it to be. Okay, now getting back to the reference box. If I start at 0, my other corner base or length, this is when I can start to use my snaps again. I still have an end snap right here. That's projecting down to the end snap. So that's drawing a base that's at that corner. And now it's asking me for my height. This is when I take the project off. And I'm going to make it be 8. So we've rescaled it, right? It used to be, now we're looking at something that's 15 by 11, and we've got that box matching that. It's got an 8-inch height. This box needs to be aligned with the very upmost elements of my surface, the very extents of it. If I look at it in this view, it needs to represent the very top part. So I'm going to use the align command again. We used the align command before. We're going to use it again. We're going to align both objects, and we're going to align them to the top. Again, it's going to ask us where to snap it to, and then you can just use the end snap again to put it exactly where it's already been. We're not moving the box location. This will move just the surface location up there. So now we're guaranteed that this box will contain it just barely. So if I look at it in a shaded view, I see a very kind of the very top part is kind of coming through because of the graphics card. You can see also, I can see the edges there, right, that are happening. This is important here. We want this the top of very top of our topography to be 8 inches off the ground, but we need to actually slice this thing using the red surface. So we're going to take this box and use this as a slice right through the solid, and it's going to leave us a top and a bottom. We don't need the top. We're going to keep the bottom. But because of the curvature of this surface, if I were to right now use this, I would get like a little flat top. It would kind of flatten off the top of my surface in my topography. So what I'm going to do is I'm going to move the top of this thing. The very important thing is that the placement of this is done, and I'm moving the top of the box up by 1 inch. I can do that using my gumball manipulator. If I hold down Control and Shift at the same time, it's going to allow me to do a sub-object selection, so I'm picking the top of the box instead of the whole box. And then if I click on my blue gumball, I can type in 1 because my model's in inches, and it's going to move the gumball up 1 inch. It's going to leave this as a solid. It's important to leave it as a solid to use solid tools. If you're having trouble with the gumball, the other way you could do it is you could scale it in 1 dimension. So I can go to transform and scale it in 1 dimension. Make sure you do the 1-dimensional scale. This is my object. My origin point is always going to be the part that doesn't move, so it's down here. My first reference point is always the existing extent of an object, so it's up here. And then I'm telling it what my second reference point is. My second reference point is 9 inches off the ground, so I type in 9. Either way, we're going to come out with a box that's 9 inches tall. So now I'm ready to slice this, it off. I'm going to use a Boolean split to do it. So under solid, I'm going to go down to Boolean split. So Boolean tools take solids in and they give you solids. That's why we like them. It will allow you to use surfaces to slice up solids. So the one thing you can use something with a thickness for is to break up an existing solid. The difference between this and using a regular split is it's kind of like slicing open just a regular box. It won't have the inside surfaces at all. It'll just slice it open, and then you'll have 2 open things. So we actually won't have a topography. We'll just have the sides of a topography. That's all we would have. So that's why we wouldn't use a Boolean split. It says delete input no. It's always good to keep your input geometry around, so I don't say delete input yes. For surfaces to split, it's my box. For cutting surfaces, it's my surface. And that Boolean split's going to run. It's going to look the same. You would know if it didn't work. It would tell you up here. It would say Boolean split failed. Up here, it worked. So I've got three things. I've got the whole thing. I've got the top, and I've got the bottom. So I'm going to take the top, and I'm going to hide that. I'm going to take our reference box here. And what I'm going to do is I'm going to take this new poly surface on the bottom and change my layer to be that topo poly surface layer up there. I'm going to take my box layer off. So I've got, my graphics card has two things in the same place. I've got this. This is what I've got left over. The reference geometry isn't important anymore. This should work. Why does it work? It has to be exactly the same boundary. So if our red surface was a little bit off and a little bit different, it wouldn't have worked. So it's very real possibility that that might happen for you. Something could have slipped. If you've gotten to this point, you don't really have to worry too bad about it. What you can do is, let's say, what I'm going to do is I'm going to make it so that I'm going to make this thing fail. And just 1 second here. So let me do that. And this will be like an exaggerated version of it, but I'm going to just move this thing out point enough for it to fail. You can see it's already kind of a bad sign when that red line surface disappears. But yours might be even closer like this and look pretty good. So when you go to run the Boolean split and you run it the same, you do everything right. So actually, let me get this stuff out here. I've got a little extra stuff. And it's going to say that failed because it's not running up against the edges, even though it kind of looks like it does. And it might look perfect. It might look like this. So one way to check in on that and find out what happened is to run the intersect command, which is under curve from objects. Intersection. And you pick your two objects and you say, show me the intersections. It'll draw curves. And this is, by doing that, my new curves are showing me that 3 out of 4 were okay, but this last one was not so great. So I need to make that intersect better. The way I do that is, now that I know that this is the face in question, I do that Control Shift and I pick it, and I take advantage of my end snaps. I grab my red arrow on the gumball, which lets me move my face and keep it a solid, and I end snap to the corner of it, and that puts it back in the spot. I don't know what that number is. Maybe it's so small it wouldn't be worth knowing. The point is I'm snapping to the existing geometry. So now that's the fix in case your Boolean split doesn't work at first. But I'm going to run it this time. And I've got very good topo poly surface there. That's what I want. Turn off my reference box layer. Turn off this layer. Okay. So going forward, the next thing that I need to do is I need to bring in my spline. So I've got my Rhino model that is where we left off last time. I've got my splines drawn in there. I've got my new splines. What I really want is my new spline, which is this one. And if you're not sure, you can always take a look at the one that runs all the way to the ends. That's a good tell on that one. And I also want to bring in my drawing border for a second. It's a good reference to have. That's going to help me get this thing lined up nice and good. I'm going to, again, copy that to my clipboard. I've got those two objects. I'm going to go back. And I'm going to take off, I'm going to paste these guys in, this stuff that I just copied. And that's pasted in this border layer, and it's also pasted in the new curve. It's called new curve. Yours might be called new spline. whatever you decide to call it. Alright, so this goes off for a second just to take a look at what we've got. It's sitting flat in there. It's too big right now. So what I'm going to do is I'm going to scale it down to fit. Scale. There's two ways to do it. If you have not had to change anything the whole time, you didn't have to do any nudging or anything, you can just do the same scale. You can pick your origin point to be 0, and you can say 0.5, right? If for some reason you had to change something, you're going to want to scale it by using the two edges of the long axis, because the most important thing is that this spline touches both ends of this guy. So let's say you had to nudge yours a little bit to get it to work. Then you want to do transform and scale it from the whole size to your new size, and that'll address that issue. All right, so I'm going to take this off, make sure I haven't skipped any parts here. All right, so now we're ready to make some copies. Or copies is what's going to give us thickness, and that's going to be what we're going to use to create the geometry that's going to slice into our topography and create our intervention. I've got my top view selected, and I'm going to do a linear array. I want perfect copies of this curve in both directions. I want 2 in both directions. So I go to transform, and I go to array, and I do a linear array. I could also do a rectangular array too. Either one would work. I'll show you the setup for the rectangular one for now. That's the older one that's been around for a while. Objects to array is this curve. The number in direction 1. Well, you always count the original. I only need 1 in X. We're going upwards, so I want 3 in the Y. I need none in the Z. None are coming at us. Y spacing is going to be 1 inch, so I hit 1. It's going to give me a preview, and if I like it and it looks good to me, I hit OK. And then I'm going to repeat that same process, and the only thing I'm going to change is when I get to the Y spacing, I'm going to change it to -1. So instead of sending things that way, I'm going to send things this way. I hit enter to accept that. Okay. So basically what we're looking at, these are the outlines of this kind of cavernous form, that the outside is up high and the inside ones come low, so the section is going to be like a V. So in order to do that, I'm going to put my geometry in the right spot. Let's see. All right. I'm going to these two, the ones right next to my original spline, those are my bottom curves, so I'm changing the object layer. The ones on the outside are my top curves, and I'm changing that object layer to be bottom and top curves. And if that's not clear enough, I'll just add some color to it so you can see what I'm talking about. So my top ones are going to go up. My bottom ones can stay. I can turn the, I'm going to make this new layer called split surfaces. And that's my active layer. Don't need the new spline right now. That was our center line. These can stay on the bottom. I'm going to move my top ones up with the gumball by just having it activated. Remember, you can get it activated down at the bottom there, and if I click on it, the arrow real quick, it'll give me a direct number, and I'm taking this up 9 inches. can take the border off. And the next thing I'm going to do, so kind of keep in mind our poly surface is like that. We're up above the poly surface at this point. It's important that we do it at 9 inches to control the section that kind of comes down to it. So what I want to do is create these kind of two surfaces that are going to come down and slice this thing into 3 parts. I want to use the Loft command to do that. It's going to give me the least amount of information between my top curve and my bottom curve. So the best thing to do is to pick them ahead of time. So if I pick them like this, and I go to surface and I use the Loft command. Depending on the last time this got used, the last time I used it, it was developables. That is not what I want. I want it to be normal. You want it to be normal. So if I hit preview, it'll update the normal. Developable is something that breaks it down into rationalized flat surfaces so you can unroll it and then rebuild it later. But we just want a nice normal loft. We don't want to have any alignment or any kind of, so we want do not simplify. We don't want splitted tangents or anything like that. It's a basic loft. It should look like this, and I hit OK. You can run the command first. You have to be careful when you do lofts that you pick near ends that want to be near each other. If curves have a direction, if you've never looked at that, if you type in dir, you can see that this curve is running from my right to the left, and it wants to connect like ends. So it doesn't want to connect the start and the start. It wants to connect the start and the start, and it doesn't know which one is which until you tell it with this command. So if I run that Loft command and I pick this curve to loft, but then I pick the other curve over at closer to its other end, like that, and then I hit OK, it's going to give me what we call like bow tie surfaces that look like that, because it's trying to run that surface across itself. It's switching directions. It doesn't have any information in between, so that's why it's all bunched up like that. It happens a lot if you're just not careful. It's not a big deal. Basically what you can do is you can hit this Align Curves button here, and by clicking on these white ends here, you can flip it, and you can just flip it back and forth until it looks right. And then when it looks good, you right click and you're still in the preview of the loft. So it's not a big deal if you see that bow tie. Don't freak out or anything like that. It's really fixable, especially with only 2 curves. It gets tougher if you're trying to loft like 40 curves. That's when it gets a little tough. So say, okay, I've got my splitting surfaces. Don't need the curves right now. I am going to go back to where my poly surface is, and I can see that this is looking pretty good because I can see my surface edges going all the way down here. So this is because I was kind of careful about taking that curve all the way across. And again, I'm going to use the same command. I'm going to use a Boolean split on this one. So I go to solid, Boolean split, down near the bottom there. My surface or poly surface to split is this. My cutting surfaces are here and here. And I'm going to get out, because I didn't put delete inputs, I'm going to get out the original. So I'm going to hide that. I'm going to get out this middle section, which I don't need. And I'm going to have my cutting surfaces. They have their own layer, so I can turn that guy off. And this is my resulting site that I've got going on here. So this site's going to go down to the bottom. This is going to sit on top of your base. And because your base is this size, that's what's going to keep this thing in the right spot. You're going to use the perimeter of it to register it out. Yeah. So the next thing we look at is how do we build it? Well, we're going to build it by stacking the cardboard that hopefully you've already bought. Not like this, but like this. We're going to do it like a slice of bread with a loaf of bread. We're going to go this way because the registration on the perimeter will keep you from not have to figure out how to get your mountaintops in the right spot, right? That's a lot of work to try to do that, and it's a lot of wasted time. This is going to give us something where you'll always know exactly where the next slice is supposed to go. So same thing, but what we're doing is instead of using, remember we did our contour command, we're going to do something similar, but we're going to go in the other direction. But we're going to use section tools because section tools is going to be something that is going to give us output instead of just giving us sliced up sections in 3-dimensional space is going to give us the ability to label and lay out our sections for the laser cutter. Section Tools is a free plugin. If you're running Rhino on your PC and you don't have it, you can just Google it. It's free. It's Raja's plugin. It's already installed in the labs. If you're using it in the labs computer, it's already installed there. So in section, I'm going to change my layer here. It's going to be, although I'll have to mess with this later, but I'm basically going to have these sections. And the first thing I need to do is create them. So this thing is down to this scale. We're assuming that the cardboard thickness is 1/4 inch. So that's going to be the separation of our sections. The way that Section Tools works is that it makes these section objects in Rhino, and it stores a running list of your section objects in Rhino. When your geometry changes that's been assigned to the sections can update themselves and output again and output again. So it's parametric in that sense. What we're going to do is we're not going to do one section, we're going to do an array of sections. So the first thing under Section Tools I'm going to do is I'm going to create an array. For the objects to section, I'm going to pick both of my pieces and press enter. It's asking me a lot of options right now. You can see a ton of these clickable options happen. And I'm going to run down them here. I'm going to do, my direction is going to change. We don't want to do it the long way. We want to cut across the short axis. So where it says direction, I'm going to change x-axis to be y-axis. And that's going to change the direction of the section. You can see that now they're pointing that way. I don't have to worry about replace. Name X is fine. It always gives it a prefix no matter what. Start index, if you're not used to starting at 0, if you don't have a computer science background, you can change this to be start index equals 1, because basically it's going to go from 0 to 59 instead of 1 to 60. It's not going to change how the geometry works, it's just going to change your labels. For number of sections, I'm going to change that to 60. For my spacing, I'm going to click on that and change that to 0.25. Any of these other options are not important. They're not affecting what's coming out. We're not using a solid mode, so you can leave that at none. Labels show all, that's fine. Arrow scale, we're not concerned on how big our arrows are right now. We're not going to use the arrows. So the important thing is that I have to tell it where to start this array. It has no idea to do it. So where it says pick base point, I can either end snap right here to the bottom left. I can also type in 0, 0, 0, and that's going to be my base point. When I enter it, it's going to run the command and build out the sections. And it's putting them on individual layers and locking those layers. So you can see now I've got 60 sections. And 60 sections in there. And they kind of look like contours, right? They kind of look exactly like the contour commits. But they have information that they remember what they're cutting through, and they have the ability to update as well. All right. So I've got my sections made. For kind of just clarity, I'm just going to select all these 60 layers, and I'm going to drop them into that section layer so it's not dominating my layer manager, because it's eating up the whole thing. So they're all in there now. But they're in my model. They're part of my Rhino model. So if you save this file, you'll have these sections as part of your Rhino model. You don't have to worry about like exporting them or something like that. Okay. I'm going to change my layer to be nested sections. I'm going to take off these layers with my info. And the next thing I'm going to do is I'm going to start to set it up to go out for the laser cutter. Most of you guys have used a laser cutter, right? Probably the majority of you. But maybe there's things you do or don't know about it. It's always good to talk about best practices. If you're a transfer student, you might be less rehearsed in it, and we definitely have plenty of transfer students. But I don't know what size your material is. You might have gotten a 4x8. You might have gotten some other size. I don't know. So what you're going to have to do is what we call nesting, and that's basically trying to optimize the orientation. But to talk about cardboard, we've got cardboard that is going, it has a corrugation direction, right? Any piece of cardboard. And what we're trying to do is we're trying to have us looking at the corrugated ends on the outside like this, right? So we should be seeing the corrugated ends along the long sides of it, and they should be fairly consistent, not like every other one or anything like that, right? Because what'll happen is we'll be able to actually see through it a little bit if we can have the corrugations pointing at us. If I'm looking at your model on the table like that, right? We don't want them pointing up towards the top. We want them coming out to the side. So that means you're either going to go like this, right, with your model, or you're going to go like this with it, depending on how you drop your piece of cardboard in there. And only you know how you're going to do that with your cardboard. Does that make sense? You want them matching up. So let's assume that you have that. The first thing, no matter what you need to do, is you need to get them all out there. And there's a couple things you can do to make your life a little easier when it comes to the setup. We're going to nest them out, because right now our sections are three-dimensional objects. They look like this. That's a lot of work to take it, flip it, sit it down. That's a lot of work. And to do that 60 times is a considerable amount of work, which is why we use the section tools, because it allows us to nest it out. I'm going to go into my section tools, and I'm going to do nest 2D layouts. It's asking me to select my sections. So I could pick them all, but since they're on locked layers and I don't feel like getting into my layer manager, I can just click this option here that says list, and it brings up a dialog that shows me all. These are all the sections, and I could have had all these different groups of sections. And I say select all, and I hit OK. So now it's asking me a couple things. It says show solids. It's not important. We can say no on that. Arrange them horizontal and vertical, so either they're going to line them out this way or they're going to line them up that way. I'm going to leave it at horizontal. The base is asking me where I start to put it. So right now it says base equals mid, and you can see I'm snapping to the middle of this section. If I change that to be a different way, I can say base equals min. That means it's the minimal, which is in the bottom left corner, and the maximum would be up in the top left corner. But mid's fine, min, if I'm worried about starting at the origin point. Spacing method. So the spacing method, the clear option basically says it's only going to space it far enough so that they don't overlap. That's going to leave my stuff side to side. That's a little too tight and a little too difficult to deal with. So to start off, I would say just give yourself an even spacing out until you decide how you're going to lay it out. So I'm going to change my space method to be base to base. What's my spacing value? Well, my model is 11 inches wide, so I'm going to give, right now I'll just do, so you guys can see clearly, I'll do a spacing value of 12 to give me an inch between each section. So I'm going to change that to 12. Still wants to know my base point, so I'm going to tell it to be 0, 0, 0. And it just dropped out 60 sections, right? Because I gave it a little bit of spacing. When I see this, I know that I'm going to the next section because the inside of my model is like this, right? Otherwise, they would have been like right up against each other. Yeah, so it's good. It gives us annotation dots, right? So I know which section is which. I know which order to put this thing together in, right? And it takes care of that. So I'm in pretty good shape. You can see that this is actually a section here. It just gets really tight all the way up there. So these annotation dots are not great for laser cutting because they don't transfer. They're just dots. They're good for us because no matter how I zoom in, they're always the same size. They don't take up a space. But I actually need, what I really would love to have is curves, and I want the least amount of curves possible to get my information across. The problem with text is typically text conversions will give you an outline. So if we look at text objects in Rhino, just in general, if I type in text, and put it down there, it's its own kind of object. By default, if I explode text, by using this, it goes into curves automatically. It goes into foreclosed curves. But this is a lot of real estate to be etching out. So what I want to do is I want to use a single stroke font. Now, I've got one here, but there's not one that's built in. So if I go to properties on any text object here, when it's still a text, so I undo and go back to when it was still a text, I've got this button here that says under properties, text, and it's telling me what the font is. I'm going to change mine to one called Rhino RHSS. It's called. It's one we made last year for this purpose, and it's called Rhino single stroke. So I click on that. Now that doesn't make a ton of sense right now, but what it is it's the number highlighted out. So I've changed it to that, and now with that change, I'm going to explode it. And now this is what test looks like in single stroke. It's saving money, or I'm sorry, well, it's kind of saving money, but it's saving time because it's not stopping and starting. It has a route for T. It only jumps when it has to. So it makes connections that allows you to still read. So it's a little hieroglyphic in the sense that you have to start realizing that. But you're going to have numbers. So if you decide to go this route, it's going to make your laser cut a lot quicker. Otherwise, you're going to be waiting some more time to etch out the numbers on something. If you've got Rhino and you're running it on your own machine, you can download this by just Googling paneling tools. If you Google paneling tools, I don't know if I'm actually connected to the internet or not. I can try, but it might not be. On that website, it'll give you a download link to do it. I'm also going to put a copy of it in the public server. There'll be a little copy of it along with the laser cutting manuals that tell you how to get things ready to go out, because it's basically a matter of changing your layer attributes and getting it ready for the laser cutter. But that font will be there too, so you can install on your machine. Unfortunately, you can't install fonts, system fonts on the machine itself, but if you've got somebody with their laptop, they can easily go in there and change your fonts for in your Rhino file. It's only by selecting, but before we do that, I've actually got to change the items here to be text. They're dots right now, right? So if I go into Rhino, I can go to edit and say select objects. I don't know if annotation dots are in here. Nope, it's not in the menu. So the command for that is SELDOTS, or actually SELDOT in case you want to just pick one of them. But because I typed that in, it's selecting all my annotation dots, and then I'm going to run the command to convert them, which is called convert dot. Now this is asking me what I want to convert it to. I say delete input equals yes, and I'm going to convert it to text. That's my text there. My height, I'm going to convert it to be, that depends on you and how good your eyesight is. Let's say 0.25. This will convert it to 1/4 inch text. You can definitely go smaller than that. It's asking me some orientation stuff, so I'll say I'll align it to the center and I'll vertical align the top. But you might have to do some changing of that, and I'm going to hit enter. That's going to change all those annotation dots to text. So now we got text. What I'm going to do real quick is change my layer to be nested numbers for these objects. I'm going to change my object layer. So now I've got them on a separate layer. I'm going to explode them. I want to change my layer because right now my curves are both going to be in the sections, and when I do this conversion, I'm going to have curves here too, and I want to keep them separated on different layers, right? When I run the explode command, or actually before I do that, I need to change the font. So let me do that. If I had that single stroke font, now's the time to change that. All right. Now explode. By default, it gives it a fill. That's why we want to explode it, because if we try to bring this into the laser, it's going to try to etch that solid thing there and make that shape. So that exploded it. And this single stroke basically gives you the outline of it. So that font's meant to be exploded to just draw outlines of things. Because Section Tools always gives us a prefix, we have an X in front of everything. That's usually because, like, if you were to do like a waffle model, you'd want to know what's in the X direction and what's in the Y direction. But since we don't need that, I can exploit the fact that this curve is open and all my other curves, and I would move all these numbers down a little bit before I laser cut it. All my other are closed, right? So if I say SEL open CRV, select open curves, I can select all the open curves in my model, and it just happens that all my open curves are X's, and I can delete those, so that's less that I have to etch in there too. So that's less to build. So now I just got numbers, and I just stack in the numbers that I've got there. At that point, it's just a matter of you organizing it the way that you want it, laser cutting it, putting it back together. Yep. And that is the last step that's going to give you your topo polysurface model, and hopefully it'll look something like that. Any questions? Yep.
For the annotated numbers, how do we get them onto, like, it looks like they're slightly off of the, where will they show up? How do we get them onto this single slice?
The single slice?
Yeah, like,
you can have it on the actual cardboard piece, or you can have it, let's say, edge on.
Yeah, it's just up to you.
So it's up to you.
Yeah.
Regardless, you put it together, you won't see it.
Yeah, yeah. It doesn't really matter where you put it. So it's whatever you're comfortable with. That's why it's good to organize it correctly, because now they're all on their own layer, and I can select those objects by layer. So I select objects on that layer, and I can just use the move command to just move up all of them simultaneously. The point is you need to work systematically with this stuff. You never do one thing for one section and ever treat it as a single object. You always do everything with everything and be systematic about it. Take the time to organize so you're not doing extra busy work. Yeah.
Would you want to put that number on both of the pieces so you don't mix the smaller pieces also?
It's up to how smart you are. Yeah, I don't know. It's up to you. You could, for sure. It wouldn't hurt. It's right there. I mean, you could find a way to do it. The problem is the size of this changes. But you could kind of quickly just do some copying over and play it safe. Yeah, it also kind of depends on how it's laid out too. But yeah, definitely. Yeah.
And the laser cutter, and are we gonna how are we gonna lay it down?
How?
Is it gonna be one file or pictures or PDF?
Depends on what laser cutter you got. Depends on what cardboard you got, right? So when it comes to the actual laser cutting guide. Those guides there's 3 guides. There's the Rhino for the cabinet laser. There's the Rhino for the industrial laser, right? That tells you how to get your Rhino file ready. So that's when you would pop that open and check it out. It's going to tell you what to do with the layer management and how to export it to a DWG. I think they use DXF in both of those as well, right? The Corel to the laser printer is a second one you're going to read if you use the cabinet, because the Corel Draw is the software that the laser cabinet uses, and it'll tell you how to get it ready. And but it's pretty straightforward. All those guides are always like 2 pages, and they tell you exactly how to set it up. And if you used it before, you'll know how to do it. But they take the DXF. The Corel will take almost anything. It'll take a PDF. It'll take an Illustrator. It'll take a DXF or anything. Since this is just line work, it's easy to just do this as a DXF. We've only got 2 layers. We've got an etch layer and a cut layer, right? That's all we got. It's not going different depths and things like that. So. What else? Is that it? All right, guys. Let me get us out of here.